Hello, good morning student. How are you? I hope you all are happy, healthy and fine at home. So, what did we discuss yesterday? Yesterday we discussed the stereochemistry for SN2 mechanism, and what do we found in a SN2 mechanism? It gets inversion of configuration that proves that the nucleophile approaches or attacks from the backside. There are three evidences or proof we have taken or we have discussed in a previous lecture, yesterday's lecture. So today we are going to discuss about the SN1 mechanism, SN1 reaction, right? The SN1 reaction, that is kinetics and mechanism. Kinetics and mechanism. That is the point of today's discussion. Let us begin with what is SN1 reaction. What is SN1 reaction? Because there are 4 mark question always appear in a university exam, that semester 8 exam. In question number 3 there are the 3 mark questions are there. Out of that you have to solve 2 of them. One I already told you, one which is appear from the chapter number 2, and second which is appear from the question number 3, and third on elimination that we will take later on. These are the 3 chapter important as far as a question number 3 is concerned. Out of that from this 5 mark question always appear in the exam. Let us see what is SN1 mechanism. Discuss with the following points, and as we know that the point during the study of SN2 reaction we have seen point kinetics, then proposed mechanism, then nucleophilic attack, transition state, then energy profile diagram, and later on is a stereochemistry. Same pattern we are going to apply here, and we are going to learn step by step this reaction also. There will be no confusion. Let us see here the what is SN1 reaction. Again, S stand for substitution, N stand for nucleophilic, and 1 indicate as a unimolecular. Why it is unimolecular? When we will study kinetic, the study of kinetic, it will show you why it is so that we will see shortly. But here remember, S stand for substitution, S stand for substitution, and N stand for nucleophilic, 1 stand for unimolecular. So this is the 1 mark, right? What is SN1 reaction? So you have to just give the full form of that. SN1 substitution nucleophilic unimolecular reaction. So that is the answer of that question, or what is that is the full form of that SN1 reaction. Now let us begin with first one is a kinetic, right? Kinetics, and as we know that kinetic in a physical chemistry you might have studied, one separate chapter is there, and kinetic we are studying the rate of the chemical reaction. That is a speciality of that. Kinetic means we are determining or we are measuring the rate of reaction, how much time required for completion of the formation of the product. So, and there are different type of the reaction condition which will affect the rate of that chemical reaction. So that study you already or you can study in the chemical kinetics in a physical chemistry. So kinetic means what? The kinetic study of this reaction showed that the rate of reaction is directly proportional to the concentration of the tertiary butyl only. Here, for before that kinetic, let us see as a what is that. First one is a general reaction you have to consider, because here consider the general reaction, consider the hydrolysis of, here remember, consider the hydrolysis of tertiary butyl bromide with aqueous sodium hydroxide to yield tertiary butanol or tertiary butyl alcohol. So this is a general reaction we have considered here. Consider the hydrolysis of tertiary butyl bromide with aqueous sodium hydroxide to yield tertiary butyl alcohol. And as we know that if SN2 reactions are there, SN2 reaction for primary halide, and that SN1 reaction you have to consider the tertiary halides. Remember, this is essential as far as SN1 mechanism and SN2 mechanism is concerned. And therefore, now let us see here what is the general reaction we have taken. You know that the structure of the tertiary butyl bromide. Do you know the structure of tertiary butyl bromide? Yes. What is that? Here let us see here. Tertiary butyl bromide is this is a center here CH-3, then one CH-3 over here, here CH-3, and here Br. This is the structure of tertiary butyl bromide. This is the structure of tertiary butyl bromide. Or IUPAC name you can consider 1, 2, 3 or 1, 2, 3 at 2 position. Bromine atom is there as well as one methyl group is present. Therefore, the IUPAC name of this compound will be like this: 2-bromo 2-methyl propane. So here, and hydrolysis, the hydrolysis with aqueous sodium. In the first step, what is happening is here we are using some solvent is here. Solvent. In a solvent there is a departure of this Br, and we are going to get here CH3. Step number first. Then here CH3 positive charge is formed here, and then the nucleophile attack here. OH minus. So nucleophile can attack either front side attack or the back side attack. But here just remember before that, just tertiary butyl bromide treated with aqueous sodium hydroxide OH, and this is a SN1 reaction. We are going to get here this compound CH3, then CH3 OH, that is a tertiary butyl alcohol, or the IUPAC name of this compound. Again, at 2 position there is a OH, again methyl group is here, so 1, 2, 3, or you can number from this side 1, 2, 3. So at 2 position OH group is here, 2-methyl 2-propanol, so that will be the IUPAC name of this compound. This is a general reaction we have considered here, and the Br minus is a leaving group here. What is happening here? OH minus is a nucleophile and Br minus is a leaving group present in this reaction, and we are getting as a this type. Now the kinetic of this reaction, the kinetic study of this reaction showed that the rate of reaction is directly proportional. Now let us look at as a kinetic of this reaction. Kinetics. Let us see here kinetics of this reaction. First point we are learning here, the kinetics. Now in the kinetics, what do you see here? In the kinetics, the rate of reaction, just the study of kinetic showed that the rate of reaction is directly proportional to the concentration of the substrate only. Here what is happening here? Kinetic study, this is an experimental study, showed that rate of reaction is mathematically, the rate of reaction is directly proportional to the concentration of the tertiary butyl, CH-3 thrice C, tertiary butyl bromide only. And therefore what do you see over here? Rate is directly proportional to the concentration of the tertiary butyl bromide only, and therefore rate is equal to K1 into concentration of CH3 thrice C Br. So where K is a rate constant for first order, where K1 is the rate constant for first order, first order, right? K1 is stand for the first order, and that's why it is known as a unimolecular, means substitution nucleophilic unimolecular reaction, because this unimolecular reaction, because only one of the molecule, 1 mole of the what we can call it as a substrate used over here, and that's why it is termed as a first order reaction. What is the next point we generally talking about this? First, second one is a proposed mechanism. Who proposed this mechanism? Do you know that? Last time I already told you that for the SN2 reaction, there is the great scientist, the Ingold studied this reaction, I think in 1925, and proposed the mechanism that is known as SN2 and SN1 mechanism. Now let us see second one is a proposed mechanism. And now we generally, while writing as a mechanism, as far as the SN1 reaction and SN2 reaction are concerned, we are using the Weiss formula, that is the representation of the organic molecule on the blackboard, because our blackboard is a two-dimensional entity. You have to study this mechanism by visualizing the three-dimensional structure, and therefore here look at here, now C, then Br and one methyl group I am putting here, look at, and shown by normal line. It clearly indicates that this methyl group, carbon and bromine, they are present in the same plane or lying in the same plane, and one bond I am showing like this dotted, and this there is a one. So this clearly indicates that the bond going away from observer, or we can call it is below the plane. And now the fourth bond I am showing here, that is which is thick or solid, and this here again CH3 group. So all this is a structure of tertiary butyl bromide. Now what happened here? Here we are in the first step number first. This is a step number first. Step first takes place here during the solvent here. Without solvent, there will be no formation of the. Here we are using solvent. And now what is happening here in the first step also, first step there is a departure of the leaving group. When that leaving group departs, what do you get here? You are going to get here the transition state like this CH3, then you may write this group here like this, and then another one CH-3, and when the leaving group departs, it taking its bonding pair along with itself and leaving the positive charge on the carbon atom, because that carbon atom becomes as an electron deficient in nature. Look at this. This is a transition state formed here, and this is a carbocation, or it is called as an intermediate. It is a short-lived intermediate form over here, and when this form, and this first step is known as rate determining step. It is known as a RDS, and as we know that RDS means what? Rate determining step. And this bond is broken. When the bond is broken, the energy evolve or energy is consumed during the breaking of bond. The breaking of bond energy is evolved during this process, right? Energies and the solvent, whatever energy is provided by the solvent, and that energy is utilized to break the bond between this carbon atom and the bromine, and therefore there is a breaking of bond. Means breaking of bond means it consumes the energy, which is known as a exothermic reaction, and that taking place over here, and we are getting as this type of the formation of the transition state. And then step number second is a very fast step. This is a very fast step. We can, and once the transition state is a form, that molecule becomes as a planar in nature. And now when that molecule is become a planar in nature, what is going to happen? The nucleophile can attack front side as well as back side. Equal chances of attacking or equal chances of approaching the nucleophile to that carbocation. Suppose it is attacking this one OH minus from front side, not from back side. What you are going to get, similar to as a SN2 reaction, you are going to get here HO, then C, this methyl group, they are as it is, then one of the methyl group I am showing like this, and one of the methyl group which is shown like this. So this type of the product we getting, that is called as a retention, right? This is called as a inversion product, inversion product, right? And now when the nucleophile may be as a OH minus or used as a solvent, so there is front side attack. So what you are going to get here OH, then one methyl group is here, one methyl group I am showing by dotted line here, CH3, another methyl group is over here, CH3. If you observe this reaction carefully in the product, one we are getting as a inversion product, second one is a retention product. Retention product. Inversion means what? Totally, if you start the reaction with the optically active substrate, then and then you can see, suppose your substrate has a R configuration, here you will get as a inversion configuration, and as well as retention configuration. When the nucleophile approaches from the front side, at that time you will get the retention type of the product. Retention means what? Suppose whatever configuration of your substrate has, that remains as it is. If your starting substrate has a R configuration, your final product will be the R configuration. So that is meaning of retention of configuration. Inversion means what? Exactly opposite. If you start with R, you must get the S configuration. If you start with S, the product will be the R configuration. So that is there. If you observe these two products carefully, what do you see? If you put here as a or this molecule, suppose as this side, if you put as a mirror, what do you see over here? They are mirror images of each other, means they are non-superimposable mirror images, and therefore they are the called as an enantiomer. Enantiomer means what? Non-superimposable mirror images of each other are known as an enantiomer. But here there is no chiral center, and as I already told you that chiral center means what? The carbon atom carrying 4 different group is known as a chiral center. If chiral substrates are there, it must be optically active in nature. If it is achiral, that organic compound is optically inactive in nature. So this is the optical activity, is one of the main property of the organic molecule, where, and that optical activity means what? The substance, the certain substance which rotate the plane of polarization through certain angle is known as optical activity, as we know that. And the instrument used to measure or to determine the optical activity, the name of that instrument is a polarimeter. Polarimeter used to determine the optical activity of the organic compound. So that is there. Now look at these are the product we are going. This is the mechanism proposed by that Ingold. Ingold is the scientist name. Ingold, he proposed this mechanism, and that's why name is given. He studied thoroughly and then he given some of the these are the conclusion. He has given an explanation about this. So now next point, what is the next point we are going to learn here? A, B, then C. As we know that is a nucleophile attack, right? Then nucleophile attack. Nucleophile attack. Nucleophile attack. What are the points to discuss in the nucleophile attack? Before that, not. C is a transition state. C is a transition state. Transition state, right? First, before the nucleophilic attack, in this case, you have to discuss about the transition state. Observe this transition state carefully. What do you see here? When the living group departs, that has a carbon. This is called as a carbonium ion, right? Carbonium ion, or it is called as a carbocation. It is known as a carbocation. Carbocation means what? The organic species carrying positive charge, that species is known as carbocation, right? This is a carbonium ion or the carbocation, and when it attains the carbocation, that molecule becomes as a planar in nature. And when, if you look at the substrate here, what type of the hybridization it has? It has a sp3 hybridization, and as we know that the bond angle of the sp3 hybridization is a 109.5 degree. Everybody knows that this one. And the structure of sp3 hybridization is a tetrahedral, and bond angle is found to be 109.5 degree. When the transition state is formed, the hybridization changes from sp3 to sp2, right? This hybridization changes from sp3 to sp2, and when sp2, we know that it has a planar geometry, right? Trigonal planar, and bond angle of that I am writing here sp2 hybridization, it has a bond angle is a 120 degree, and when it has a bond angle 120 degree, there is a some relief in the angle of strain that 109.5 degree to 120 degree, and therefore there is a relief in a angle of strain. And now there is a first step only the formation of the bond. When the formation of the bond taking place, so we cannot determine, we cannot measure the rate of the reaction. So but there are, when this molecule becomes as a planar one, there is a equal chances of attacking nucleophile. Nucleophile can attack from back side as well as it can attack from the front side, and when it attacking from the front side, reaction takes place according to as a SN2 reaction, and we are getting the product is a inversion product. When the nucleophile approaches from the front side, the product obtained is a retention in configuration. Retention and the inversion is totally different, and therefore, and when this product is formed, again this transition state is going to the hybridization is just changes. What is happening there? sp2 hybridization again changes into sp3 hybridization. These are the changes taking place here when sp3 hybridization, and as we know that it is the tetrahedral geometry and has a bond angle 109.5 degree. So this is all about the transition state here. Now what is the next point to discuss over here? Next point will be the A, B, C, D. D point we are talking about the nucleophile attack. Nucleophile attack, right? Nucleophile attack or attack of nucleophile. You can you can say nucleophile attack or attack of nucleophile is a better word. You can attack of nucleophile, attack of nucleophile, attack of nucleophile, attack of nucleophile. If you see over here, after formation of the transition state, that molecule carbocation is a planar in geometry, trigonal planar, so there are equal chances of attack of nucleophile. This nucleophile attack from backside, suppose let us consider here, when it attacking from the backside, then the product form is a inversion product. When the nucleophile attack from the front side, then the product obtained is a retention product. If you start this reaction with the optically active substrate, then and then you will observe this. When this inversion and the retention, two products are there, and they are known as racemic mixture. Have you heard this word? Racemic mixture. Have you heard racemization? Racemic mixture, this one. Racemic mixture means there are equal chances of formation of this one inversion product as well as retention, and that type of the mixture is called as a racemic mixture. And as we know that there is a 50% of inversion as 50% inversion as well as 50% retention, and the form the mixture that is only that is the 50%, and that mixture is known as a racemic mixture. And racemic mixture, two molecules are involved, and therefore this mixture, what is the nature of this, whether it is optically active or optically inactive in nature? It is optically inactive in nature, because whatever rotation generated by this inversion is exactly cancelled by this retention, and therefore the racemic mixture are optically inactive in nature. I think with this next point we are going to learn that I think energy profile diagram and the stereochemistry of that SN1 reaction. We will see tomorrow's lecture. With this, let us stop today here. Have a nice day. Thank you.